Alright, here's what we're going to do today. We're going to go over lesson 2.2 for my Algebra 1 students. We have wrapped up that lesson on relations, identifying a function, and looking a little bit into the inverse of functions. Today we're going to go over evaluating those functions, which we are going to introduce a topic called function notation to you. Okay, so we're going to start off, we're going to define a function rule and function notation to you. This function rule, what this simply does is this is going to describe an output or the result of something in terms of our input variable. Okay, and this is simply another way to write some equations that we've already been writing. Okay, so you take a look at these down here, you'll notice that everything in green is what these things are equal to. Okay, so for this reason, our green values here are our outputs. Okay, and everything in red are the variables that we are essentially plugging into the equation, right? So our red variables here are our inputs. Okay, so we're going to give you an example of an equation written in function notation right here, and this is read as f of x is equal to x minus 2, and this is what we call a function rule that is written in function notation. Alright, now going through and kind of analyzing this that's written in function notation. F is simply the name of the function or the rule that we are talking about. So this is function f. The x value is the input. It is the value that we're going to choose, put into this equation so we can then get our output for our function. Okay. F of x is in fact the output value when the rule f is applied to that input x. So this all agrees here. You'll notice, remember, this function rule was an output value in terms of an input value. You look down here, f of x is the output value when the rule f is applied to that input. So that's what that means, in terms of this input value down here. Now as we write it, we're used to seeing a y over here in slope-intercept form. So this f of x has simply been substituted in for y, which was typically referred to as our output. You may have heard me read this already. This f and then parentheses x is read f of x. Now, probably the most important thing to realize right now at this time is that f of x does not imply f being multiplied by x. It does not imply that. This is not, absolutely N-O-T, not f times x. It is simply notation, another way to write y and we're writing that in function notation. Just to give you an idea, here's a visual. We'll call this box here in the middle is like a function machine, and you take this input value, let's do this in red, you take this input value of x and you're going to put it into this function f, and that function machine is going to spit out the output, which is f of x. Again, that does not imply f times x. Okay? It is simply notation. Now, there are also countless other notations that can be used in addition to f of x. You don't have to use f as a function or to represent your function. You can use h, g, w, and your input does not always have to be x. You can have h of x or g of x, but you could also have something like this, w of t or f of t. It just depends what you want to use. Okay? Well, let's move on. Whoops, back here. So that was defining these function rules and function notation. Now we're going to move on to three other topics. The first being we are going to evaluate these functions. Okay? So let's first look here at what this really means. We're going to substitute in and evaluate the right side of these function rules or these equations. So let's go ahead and start here. I've got f of x is equal to 3x plus 4. Okay? So that is our function notation. Okay? Now I want to evaluate that for x equals negative 3. The first thing you're going to do is substitute. Okay, let me check something here real quick. What I did. Yep, we're fine. Want to make sure I didn't mess up there. Okay, so when we substitute that in, especially when you're substituting in a negative value, when you go over here to the right hand side, I would highly recommend putting it in parentheses. So I'm going to have 3 times x, which is now negative 3, plus 4. Okay? And then we're just going to simplify from there. Okay? So 3 times negative 3 is negative 9 plus 4. And negative 9 plus 4, as we know, is negative 5. Okay? So let's take a look over here at the next one. It says evaluate f of x equals 4x minus 5 for f of t plus 2. Now, what that is doing is that is substituting t plus 2 in for x. Okay? So by substituting, here's what we're going to do. We're going to have 4 times what x is equal to now, and x is, instead of x, we've got t plus 2. So t plus 2. And then I have to continue on and have minus 5. Now when I go to simplify, I'm going to distribute the 4t plus 8 minus 5, and then continue simplifying. I have 4t, 8 minus 5 is positive 3. So I'm left with f of t plus 2 equals 4t plus 3. Okay. So now it says find f of 5 if f of x equals x squared plus 2x plus 3. When I substitute in, I've now got f of 5 instead of f of x. And I'm now going to have, instead of x squared, I've got 5 squared plus 2 times 5 plus 3. And now I just simplify. 5 squared is 25. 2 times 5 is 10 plus 3. I add all of my like terms there and I get f of 5 is equal to 38. Okay. So that is evaluating those functions, or essentially plugging in a value. Okay, plugging in a value to that function notation. All right. Now we're going to evaluate functions for a given domain. Or remember, the domain are our inputs. So for a given number of x values that we're going to put in. And what this simply means is evaluating for multiple inputs. So it wants us to find the range of this function right here for this domain, -2, 0, and 4. Well, what that means is I'm going to have, I'm going to plug in -2 into that equation. I'm going to plug in 0 there, and I'm going to plug in 4. Okay? So why don't you guys go ahead and try to do that on your own. Push pause for just a second, and then you can come back after you're done. Alright, so f of -2, if I'm plugging that in, I'm going to have 4 times -2 minus 2, right? Which is -8 minus 2, which gives me -10. I plug in a 0 there. I've got 4 times 0 minus 2. That is 0 minus 2, which gives me -2. And lastly, I plug a 4 in there. I would have 4 times 4 minus 2. So that would be 16 minus 2, which would be 14. Therefore, if I have a domain of -2, 0, and 4, I will have a range of the output values, which was -10, -2, and 14. Okay. And the last thing we're going to cover on this particular page is creating a new function. And what this means is if we've got two functions, they can be combined using the 4 basic operations: addition, subtraction, multiplication, or division. Okay? So let's take a look here. Start off here. F of x, or f plus g of x. So what that means is I'm going to want to take f of x and add g of x. Likewise, in this next one, f minus g of x means I'm going to take f of x minus g of x. And you can imagine what we're going to do in these next two. Here I'm multiplying. Here I am dividing. So the division sign in there instead of writing it as a fraction. Okay. So if I have this for my function f and this for my function g, I want to go and I'm going to solve each of these new functions down here at the bottom. So bear with me and we'll go through this kind of slow. F plus g of 4. Well, I should know that that means I'm going to want f of 4 plus g of 4, which means I need to substitute 4 into each one. Okay? So as I substitute 4 into f of x, I end up right here. 2 times 4 plus 3. Okay, that I've substituted that in there. And then I'm going to add g of 4. If I substitute 4 into there, well, it's simply a 4, right? So now I just have to simplify, and that would be, whoops, 8 plus 3 plus 4, which we know is 15. Works the same way. F minus g of 4, well, I'm going to have f of 4 minus g of 4. Going to substitute in the same way. 2 times 4 plus 3. But now I'm going to subtract when I substitute in 4 into g of x. So now I'm going to subtract 4. So as I simplify, I've got 8 plus 3 minus 4. 11 minus 4 is 7. Now, a little bit more complicated here when I start multiplying these functions together. F of 4 times g of 4. Well, f of 4, we've done that several times now, so we've got 2 times 4, plus 3. Now I also want to show that, entire thing as being multiplied by g of 4, which is 4. So I need to understand that I need to take care of this entire function before I can multiply it. Okay? So 2 times 4 would be 8. So I've got 8 plus 3 here. And I'm going to take that whole thing times 4 once I get it. So I've got 11 times 4, which is 44. Everybody hopefully sees that. If not, pause it. Maybe take a look down through the steps again. Okay. The last one here, I'm going to have f of 4 divided by g of 4. So again, I've plugged all these in before, so I'm going to have 2 times 4 plus 3, that's f of 4, and I'm going to divide that by 4, right? Well, this is going to be 8 plus 3 over 4, which I know is 11 over 4. So that is creating a new function using the 4 basic operations. Okay, we'll move on. Now what we're going to do real quick, we went over last time a little bit of finding the inverse of a function, or inverse of a relation, right? So we'll do that a little bit more in depth here. Recall that when we found the inverse of, let's make our color red here, we found an inverse of a relation, we simply switched, x and y and solved for y, right? Remember doing that, hopefully? Well, the process for these functions is similar to that. One of the differences is going to be the notation, just like we're now using function notation, right? So the notation, the inverse of f of x is going to be f. Now you're going to see a little -1. It looks like an exponent. That implies the inverse of. The inverse of f of x is how you would read that. Okay, so let's go ahead and just work through an example here. We're going to find the inverse of f of x equals quantity 2x minus 3 divided by 3. Step 1 is going to be to rewrite the equation using y. Okay, so now instead of f of x, I'm going to write y. y equals 2x minus 3 over 3. And if you remember, our first step was to switch x and y. So we're going to go do that. Now I've got x equals 2x minus 3 over, whoops, I'm sorry. That would be 2y minus 3, right? Because I switched them. Over 3. And now we are going to solve the new equation. So I'm going to start here with my existing. I've got x equals 2y minus 3 over 3. You should know that the first thing I would do is multiply both sides by 3, right? That would get rid of the 3 over here. So I would end up with 3x equals 2y minus 3. Hopefully everybody sees that. And then I want to solve for y, right? So I want to move the 3. How would I move the 3? I would add it. So I would end up with 3x plus 3 equals 2y. Okay. And then, to finish that off, I would divide by 2, right? So I'm going to also rewrite this at the same time. When I divided by 2, I would end up with just a y. And I would just have this side divided by 2. 3x plus 3 over 2. Okay. So I've now solved the equation for y. Step number 4 is again going to be to rewrite. Only now I'm going to go back. We're going to rewrite that using function notation. So f negative 1 of x, or the inverse of f of x, is equal to 3x plus 3 over 2. Now there will also be some instances where we want to write this in slope-intercept form. Slope-intercept form. And there you simply have to recognize, again I've got the inverse of f of x, that this 2 applies to both terms. This would be 3x over 2, or 3 halves x, and this would be plus 3 over 2. Okay. And the good thing about that is it gives us our slope, which would be 3 over 2. Whoops. 3 over 2. And our y-intercept, which is also 3 over 2. So that would have a slope of 3 over 2 and a y-intercept of 3 over 2, or 1.5. Alright. Now we're going to wrap up the notes today by figuring out how to evaluate whether the inverse of a function is also a function, because there's nothing saying that it has to be. Okay? So how can we tell if the inverse of a function is a function itself? Alright? If we've got this original function right here, 3x minus 2, if for the domain -2, -1, 0, 1, and 2, we want to find out, is the inverse a function? Okay? Well, the first thing I'm going to have to do is I'm going to have to evaluate the function for each of the given domain values. So that means that you're going to have to plug each one of these values in for x and get a value for f of x. Alright, so you're going to have f of -2, f of negative 1, f of 0, f of 1, f of 2. Why don't you guys try to do this right here? Hit pause and go ahead and complete that. Those 5 values. So now you'll get 5 range values. Okay, hopefully you've got that. And there's all my work. You can pause if you need to, just to make sure that you got all of those values. And next we will go down and we will write these ordered pairs of this function. So we're going to write these ordered pairs of the function. Well, that first one, our input or our x value was negative 2, right? And our output, what we got after doing that, is negative 8. So go ahead and hit pause and write out the remainder of those ordered pairs. Alright, now that you're back, hopefully this is the remainder of what you have. Now what I would like for you to do is go ahead and start listing the inverse points. So remember, how do you find an inverse of a point? You simply reverse the values, right? So hit pause and list those inverse points. And now that you're back, you'll see you simply reverse those, right? Okay. Now, step 5, we're going to graph the inverse and use the vertical line test to see if in fact it is a function. So I'll give you a second just to graph all those points on this graph that I've made. Hit pause if you need to. Okay, now that you're back, there they are. And using the vertical line test, could I draw a vertical line anywhere that's going to go through more than one point? Well, to me, it does not appear that I could. So I could say that this inverse is a function as it passes the vertical line test. Okay. Just real quick, another way that you could have done this other than graphing the points and checking the vertical line test, you could have gone back to the mapping diagram that we went over in the first lesson, if you're more comfortable with that. Okay. When you come back, you will have a substitute, and you will do a daily problem based on this lesson that you've reviewed right here, along with a homework check over last time's homework. Remember, you did the practice problems while you were in class. So you'll have a homework check over lesson 2-1, lesson practice problems, and you'll have a daily problem over this lesson that you've just concluded. And I will be back on Monday the 21st.